Hello again, my name is Adam Martinac. I'm a distance student in the IA 561 class. I'm here to make my final project presentation, so I'm going to go ahead and get started with that. So I'm still trying to get used to making YouTube videos with a PowerPoint presentation, so forgive the periods of inactivity here as the slides flash across the screen. But I'm going to go ahead with an introduction as to kind of what I do, a little bit of background information about me and the company I work for. First off, I'm a process engineer with Almaco, and I've been there for just about 2.5 years, a little over. A little information about the company. We employ about 300 people. We're located just east of Ames in Nevada, Iowa, and our industry that we manufacture for is ag equipment used in the seed research industry. This is anything from combines to planters and small threshers that are used by seed research companies like Pioneer, Monsanto. We also supply to several universities, including Iowa State, as well as the U.S. government. The USDA purchases our equipment as well. For a little bit more information on the company, you can go to our company website, www.almaco.com, which you'll see on the next slide here in a second. So the following slide coming up here will give a couple pictures of some of the equipment that we produce. What's pictured is a SHP 90 combine, which is the largest combine that we make, as well as one of the grain drills that we do. And this is just to give you guys an idea of some of the products that we produce at Almaco. So now I'm going to get into the SAPI model and how that applies to the company that I work for. So starting at the beginning, steps 1 and 2, you identify the stakeholders, prioritize them, and then determine the needs and the wants. We've actually been going through a very similar process to the SAPI model. I don't know that anybody's called it the SAPI model at Almaco, but we've been going through this because we had some serious quality issues a couple years ago. And so what we did is we first tried to identify the most important stakeholders, which is exactly what step 1 and 2 is. Basically, the stakeholders are listed here on the left column. We have our customers, which is the most important, which includes universities, corporations, and U.S. government. Other stakeholders, seed research industry in general, the workforce of both current and prospective employees, the owners of the company. We're a family-owned private company, so they're also a stakeholder. Engineering I listed on there. We're an engineering-heavy company, so we rely quite a bit on new designs and manufacturing in order to keep our customers happy. The city of Nevada, since Nevada is a small town, they really rely heavily on a large company like Almaco, who employs 300 people, most of which live locally in the city, to help provide some economic stability to the area. And then last, we have our suppliers. So since the customers are the most important, I've determined needs and wants. Some of the needs: equipment that is above all safe to operate and maintain, equipment that operates as intended upon startup with no breakdowns, equipment that meets the planning, harvesting, and data collection needs of their operations. And some of the wants, kind of more general stuff: equipment that's aesthetically pleasing, and then equipment that is efficient and runs with minimal impact to the environment. The issue that is bold and italicized and in red: equipment that operates as intended upon startup with no breakdowns. This is what we deemed the most important of the needs and wants of the customer. So step 3 of the SAPI model is to develop operational definitions for stakeholder quality characteristics. So we know from steps 1 and 2 that we want equipment that operates as intended upon startup with no breakdowns. So how do we define this? Almaco came up with the definition of a piece of equipment being field ready upon receipt by the customer. And what this implies is that there is 0 defects at the time that the customer receives the equipment, and that the equipment will fire up without issue when they're ready to either plant or harvest the material that they are dealing with that year. Step 4 of the SAPI model is then to translate stakeholder quality characteristics into producible quality characteristics. So we know that the stakeholder quality characteristic is equipment that is field ready upon receipt. And then the producible quality characteristic becomes no defects reach the customer. And this is what we started using at Almaco. We started implementing new processes to try and ensure that no defects were going to reach the customer to ensure that the product is field ready. Step 5 of the SAPI model is then to develop operational definitions for producible quality characteristics. So like I mentioned previously, new quality assurance processes were implemented to test the equipment prior to shipping. Basically, the newest process we implemented was a testing process, which took some of our more experienced personnel that have dealt with the equipment a lot and put them in a position to test the equipment as if they were the customer, since they have dealt with customers in the past and they know the intent of the equipment and how it's supposed to operate. They were then going to go through the piece of equipment to try and find any defects that existed after we had already gone through our quality inspection process. Basically from this, we started measuring the number of defects found in this process with obviously an ultimate goal of there being 0 defects. Steps 6 and 7 of the SAPI model deal with identifying processes within which quality characteristics are produced, and then developing knowledge of the processes. What we did at Almaco is when we were looking for processes to improve in order to improve the quality of our product, we focused initially on the final assembly areas. So we went through there and we looked at the information that they were given and they used in order to build and complete a piece of equipment while it was in final assembly. So we focused on this information, the processes available to them, and basically what we did is we focused on it to eliminate the variation in order to standardize the processes and create common ground that all of these guys were operating on. In order to develop knowledge of the processes, we used work instructions, quality alerts, and the creation of acceptable standards in order to get everybody on the same page and create the same expectations between engineering, production, final assembly, quality assurance, and even the customer in some instances that when they were questioning what we were doing, when we were producing a piece of equipment for them. So as far as steps in the SAPI model, that's about all I'm going to cover right now. You guys can obviously go and review the steps as they were laid out to us in the notes, but I want to make sure I explained kind of how we approach quality issues from a process perspective actually in industry and how it's worked to our benefit. So like I previously mentioned, we had some quality issues back in 2012. We had some pretty rough relationships with some of our customers, some of our bigger customers, and things weren't exactly going as we wanted them to, obviously. So we took a step back, and at the beginning of 2013, we started getting more involved with manufacturing engineers and process engineers and really taking a look at what we could do with the groups, production and assembly groups within the company in order to improve the quality of our product. So we had a couple of process engineers rather. We assigned one with the planner group, and that would be me, and then another guy that is working with the combines. And basically what we do is we track all the defects that come through, and we have a database that we call the quality management system. And this tracks all the defects that are found in the inspection and the testing phases after the product is completed. So we sift through these defects and we use your typical FMEA scoring, severity, detection, frequency, and we assign an RPN number to it. And then based on the severity of that issue, of all the issues, we attack the ones that are deemed the most severe, score the highest. So as we continue to go through these, issues, we've noticed that a lot of it, when we've broken down the problem, has led to poor processes, no standard defined, information on the floor is incomplete. There are revisions to prints that never got updated on the floor. A lot of little things that had a serious impact on our ability to perform at a high level. So as we've corrected these things, we've seen a pretty drastic improvement in the quality of our product, and also a pretty good turnaround in the perception of our product from the customer. So like I mentioned, we were using a field ready metric to track the success of our group, and field ready was defined as equipment that reaches the customer having 0 defects. Basically the way we track this is we perform in-field orientations with most of our new equipment. So if a customer buys a new piece of equipment, what we do is we send out one of our service reps, and they basically go over the piece of equipment and its functionality and how it is to be used with the customer in order to ensure that they know exactly what its capabilities are and how to operate it. Before the orientation takes place, that service group member will do a quick review of the product to make sure that it is ready to go before the customer sees it. We call this a post-delivery inspection. It's just a quick go-around. So on these IFOs, if a service guy finds any defects, that is marked as a fail. No defects would obviously be a pass, and so we calculate this as a percentage. On the next slide, you'll see kind of our performance and how we've been able to improve over the last year. 2013, I believe that our field ready percentage was somewhere around 40%. And so far this year, since we've been tracking it, we've improved up to 60. So we've made a 20% improvement on the product quality in the eyes of the customer, just by basically attacking the processes and the information and creating standards and doing some pretty basic stuff in order to improve product quality. If you guys have any questions about my project or want to hear more about what we're doing here at Almaco, please let me know. My email address is martinac@iastate.edu. It's spelled MARTINAC, and that's at iastate.edu. Thanks for your time, guys.